Hey everyone, this video is going to go over molecule and mole conversions. All right, this is going to be really similar to what we did the last time we did moles with atoms, but this time we're really going to be changing our terminology. So last time we were talking about elements like copper or zinc or arsenic. And so our representative particle for those things was the atom. This time, we're going to be talking about covalent substances like nitrogen dioxide or carbon monoxide or hydrogen gas. And so those are all covalently bonded substances, which makes them molecules. So we're going to be changing our representative particle from atoms to molecules, but we're going to use that term the same way that we use the term atoms. So here you can see I've got a couple of different covalently bonded substances here. I've got some sugar, I've got some water, and I've got some diatomic hydrogen. And I've circled one molecule in each of those things. Molecules can range in size from just two things, like in a diatomic hydrogen substance, to a whole bunch of atoms bonded together, like our sugar molecule. But one whole molecule is whatever that substance is, all bonded together. Okay, and that's what we're talking about here. We're talking about the molecules that are covalently bonded. So we already know from the atoms unit that 1 mole of a substance is equal to 6.02 times 10 to the 23 atoms. That's 1 mole of an element. Okay, so 1 mole of zinc or 1 mole of copper or 1 mole of arsenic is 6.02 times 10 to the 23 atoms. This time, we're going to be talking about, like I said, covalently bonded substances. So 1 mole of a covalent substance means that we have 6.02 times 10 to the 23 molecules of that substance. But we're going to use it the same way. So these are our practice problems on the notes page. And so we're going to solve the problems the same way that we've been solving them in the past. So we always start by writing our given. We have 3.891 times 10 to the 24th. We need to put our units, so molecules, and we need to put our substance, CO2. We're going to multiply that by a conversion factor. So whatever unit we start with, remember that unit has to go at the bottom. So we have to put molecules of CO2 down here. And the number that's going to go with molecules is going to be our Avogadro's number, 6.02 times 10 to the 23. We know that 6.02 times 10 to the 23 molecules of CO2 is going to be equal to 1 mole of CO2. And since we're looking for moles for our answer and we have moles up at the top of our conversion factor, we're done setting up our problem and we can go ahead and solve. So when you plug these into your calculator and you put your given in, you do 3.891 second EE 24, no funny business, remember, divided by 6.02 second E23. You need to be doing these at the same time I am to make sure you're getting the same answer on your calculator. We're going to be dividing because the Avogadro's number is in the bottom. Our sig figs, remember, are always based off of our starting value. So our starting value here has 4 sig figs, which means we're going to have 4 sig figs in our answer. And we would round this to 6.463. Oops, don't know what I did there, 463. And our units are going to be moles of CO2. All right, any questions? Sorry, of course I haven't. All right, so let me move on to the next one. How many molecules are in 0.445 moles of sulfur hexafluoride? So we have 0.445 moles, and sulfur hexafluoride is written SF6 times, now whatever unit we're starting with, remember that unit is going to go at the bottom, so we'll have moles of SF6 here at the bottom. The number that's always going to go with moles is 1. And we know that 1 mole of SF6 is equal to 6.02 times 10 to the 23, and we can go ahead and abbreviate molecules as cules. SF6. And we can go ahead and solve because we're looking for molecules. I don't know why I put a line there. We're looking for molecules and we have molecules up at the top of our conversion factor. So we're going to go ahead and put 0.445 times, because Avogadro's number is in the top, 6.02 second E23 And we're going to round it to 3 sig figs because our given has 3 sig figs. So our answer would be 2.68. And notice in your calculator it says E23 at the end, so that means it's times 10 to the 23. Molecules of SF6. Right? Easy peasy. So this one's going to be just a little bit different. We start again by writing our given, 0.621 moles of ammonia. So we're trying to find atoms of hydrogen this time. So we're going to multiply it by a conversion factor. So we have moles of ammonia, so we have moles of ammonia down here. And the number that goes with moles is always going to be 1. So we have 1 mole of ammonia. Now we know that 1 mole of ammonia is equal to Avogadro's number, 6.02 times 10 to the 23. But 6.02 times 10 to the 23 what? It's so easy for students to put atoms of hydrogen here because that's what we're looking for in our answer, but that's not what we're working with. We've got 1 mole of ammonia at the bottom. That means we're not talking about atoms yet, we're talking about molecules. So we need to make sure that we use molecules for our unit up here with Avogadro's number, molecules of NH3. We're not done now setting it up because we are looking for atoms of hydrogen and we have molecules of ammonia. So we have to multiply by a conversion factor, and we're going to have molecules of ammonia down here. Now we can tell looking at this formula that in a molecule of ammonia, we are going to have 3 atoms of hydrogen. So for every 1 ammonia molecule, we have 3 atoms of hydrogen. And then we're done setting up this problem, and we can go ahead and solve. So we would have 0.621 times Avogadro's number, 6.02, second EE23 because it's in the top, times it by 3 because it's in the top. We're going to round it to 3 sig figs because of our given here. And we would get for our answer 1.12 times 10 to the 24 atoms of H. Okay, so that's how you go from moles of a covalently bonded substance to atoms within that substance itself. Okay? Oops. So this question, how many atoms of oxygen are in 2.03 moles of dinitrogen tetroxide? So it's very, very similar to the last one. We're going to start with our given 2.03 moles of N2O4. Make sure you're paying attention to those prefixes. Whatever unit you're studying with, remember that unit is going to go here at the bottom. So we have moles of N2O4. What number are we always going to put with moles? 1. We know that 1 mole of N2O4 is equal to 6.02 times 10 to the 23. But 6.02 times 10 to the 23 what? Molecules of N2O4. Because N2O4 is a covalently bonded substance. We're going to multiply that by, as we're looking for atoms of oxygen, and we're not there yet, we're still in molecules. So for every 1 molecule of N2O4, we are going to have 4 atoms of oxygen. And since we're looking for atoms of oxygen and we have atoms of oxygen at the top, we're done setting up our problem and we can go ahead and solve. So we have 2.03 times Avogadro's number because it's in the top, 6.02, second E23, times 4 because it's in the top. We're going to have 3 sig figs because of our starting value. So we're going to round our answer to 4.89 times 10 to the 24th atoms of O. All right. So that's how we do conversions involving molecules and moles, and then going into atoms. Our next video will go over the molar mass of covalent substances.